quadratic functions. They are our equations that look like this. Y equals ax squared plus bx plus c, where a cannot equal 0. So I'm just going to give a few examples here. I'm going to do our red parabola. This guy actually right here is our parent function. Okay, it starts there. We can also have something that looks like this. We always want to make sure that we have arrowheads on the ends of our graphs. Or we have something that looks like this. So this right here, I'm just going to highlight them in yellow. This right here, this right here, this right here. The highlighted portions in are going to be what we call our max or min. This one right here is a min because it's the least y value, it's the smallest y value that this can become. This one right here is a max because this is the maximum that the y value can be because it opens down. This one right here, just like our green friend, is going to be a minimum. So when we look at the exponents on the graphs, we're saying that the degree, the highest exponent is going to be 2, so it's of degree 2. The number of x-intercepts, now I'm going to just draw one more in here, okay? I'm going to draw one that looks like number of x-intercepts changes depending on where the graph is. So this one right here, our green friend, we have 0 intercepts. It never touches the x-axis. Same with our blue friend here. It never touches the x-axis. However, our red friend here touches once. And our black graph here is going to be touching 2 times. So the number of x-intercepts really depends on the graph itself. You can have 0, 1, or 2. Here's the thing, we're always just going to have one x-intercept. But there will never be a case where it doesn't touch at all, and it will never have a case where there's more than one. It will always be one. So with a curve here, we're going to talk about the end behavior. So we're going to talk about a positive leading coefficient and a negative leading coefficient. Remember, this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Let's look at our calculator here. So if I were to put in my graphing, I'm going to clear the linear functions that we're dealing with. So if I were to say something like 2x, I can either say to the power of 2, or I can say squared there. I'm going to graph it. So if I have a positive leading coefficient, we are going, so it was positive 2. We're going from quadrant 2, okay, from here, to quadrant 1. So if it's positive, we're going quadrant 2 to quadrant 1. However, if it's a negative leading coefficient, let's go back into our graphs, and I'm going to say negative 5x squared. Now, and I can say plus 3x minus 6, and I'm going to graph it. Right there. Now with this one, we're going from this quadrant, which is quadrant 3, to quadrant 4. So if we have a leading coefficient, we're going from quadrant 3 to quadrant 4. Domains, if we can remember from last year in grade 11 with quadratics, are pretty easy. It's just going to be x such that x is an element of the reals, because it covers all x values. Our range, now here's the tricky bit. If we have something that opens up and is a minimum, we're going to say, so if it's a min, we're going to say y such that y is greater than the min. Y is an element of the reals. So this would be for our positive leading coefficient. Or if we have a max situation, So something that looks like this. We're saying that the graph is below this maximum point. So y such that y is less than the max. Y is an element of the reals. This is for our negative leading coefficient. Number of turning points, we will always just have one, because either it's increasing and it turns to decreasing, or it's decreasing and it turns to increasing. But this shape of the parabola will only have one turning point.